Hi, everyone. I'm William Morgan. I am the host of the AI and Kubernetes Show. I am very privileged today to be joined by Evaline Ju. Evaline, could you please introduce yourself?
Hi, and thanks for the invitation to the show. I'm a software engineer in IBM Research. And in the past few years, I've basically been getting more into the trust in AI space. And so we sort of started with looking at how explainability and fairness algorithms for encoder models would be brought from research algorithms to production. And from there, obviously, with the different LLMs and agents coming in, everyone started to ask, oh, what does trust in AI mean for all of that? So now in IBM Research, I work on this project called Kagenti. It's an open source project, K agent with an I at the end, not to be confused with Kagent, the project. And so there, we're basically working on a platform or middleware for Kubernetes where it's basically agent framework neutral. You can bring all your different sorts of agent implementations, whether it's LangChain, Crew AI, all of those. And we're focusing on security first and governance first patterns. So basically, I'm more focused on the guardrails for gateway level and observability aspects, looking at how we can look at platform primitives or patterns to be able to do the observability for all these different agents or guardrail them at the gateway or platform layer. And we're also really curious about how we can bring these patterns to the wider Kubernetes community. So I'm starting to participate in some of the Kubernetes special interest groups that we could talk about a bit later, like the Agentic Networking group, for example.
Yeah. Yeah, great. Okay, wow. So I've got about 100 questions for you, but let me start, by just trying to provide some context for our honorable listeners. So you were doing this kind of prior to the big wave in LLM kind of adoption, or your work, did it start kind of like around the same time?
So a couple years ago, yeah, everyone was focused on the more encoder models. So at the
Hmm.
time, we were really focusing on how do we bring the more like, I guess it's pretty traditional right now, the explainability algorithms like SHAP and Lime.
Okay.
How do we bring those to different applications and like bundle them together in a way that is easy to bring to all the different IBM products, for example, to be easily reused. And
Got it.
so a lot of those algorithms weren't so easily transferable to like LMs and agent applications today. So yeah, like we've really had to pivot with how all of that means when we got to like the LM and agent space in the last few years.
Gotcha. Okay. So for those of us whose interactions with LLMs is primarily by like typing into a little chat window and talking about our emotions, what's an encoder model and like how is that different from uh LLMs?
Yeah, so encoder models, we can think of them as more of like the legacy, I guess, transformer models where you type like your words into it and like numbers come out. I don't know if that's the best explanation for it, but like at the decoding aspect, you kind of get like text to text back is how I very simply think of it. And so, yeah, when you're typing into your chat widget and then using the LLMs, you get text back.
Hmm. I see. Okay. And there's still like a transformer kind of like GPT. I don't know what it stands for, but the T is transformer, isn't it? Well, I hope so. Okay, I'm going to say that. Yeah. Okay. So you started this work on kind of like a previous iteration of AI, and then LLMs showed up and gained a lot of popularity, and you had to kind of adapt it to that technology. Is that right?
Yeah, so basically, I've been working on this sort of infrastructure to provide all of these different algorithms. To be clear, I'm not a specialist on the algorithms
Yeah. Yeah.
themselves.
Gotcha.
So mostly, how do we support all these different research algorithms from our researchers at IBM Research, for example, to be brought to all these different applications?
Okay. And then, your work is around things like guardrails, and definitely I want to ask you about that. But you also said explainability. Like, what's the relationship between explainability and guardrails? Is there
Yeah.
one?
So yeah, guardrails can also take a lot of different definitions. Like for for example, people might think of even just rate limiting as a sort of guardrail. You're trying to
Mhm.
prevent your application from doing something unexpected in a way. So guardrails can have a lot of definitions. A lot of what we've focused on perhaps at the gateway level is also how does this look like from a content moderation perspective. So
Else.
yeah, so I think of it all under the blanket of how do we create trust in AI. So explainability for traditional algorithms may look like, okay, like this was the label that could be associated with it. What was the source of the original like training data, for
Mhm.
example, that would have led to this particular decision? And that's easy to attribute. But for LLMs, it's it's a little bit harder to sort of necessarily point at the particular like piece of information. A lot of
Yeah.
the time you will have to you'll see people like prompt LLMs again to be like cite this piece of data, and then you might have to still look at it and wonder, okay, is that an actual source or not?
Mhm.
So
Yeah.
that's those are some of the patterns we're
Yeah,
thinking
yeah,
about.
okay. Okay, so, I think you're kind of answering the next question that I was gonna ask you, which is, okay, guardrails, you're saying are, you can that's a pretty generic term, and so things like rate limits or is a form of guardrails. For LLMs, so they have these specific, like, characteristics where we need, different types of guardrails for them. Is that right?
Yeah, so a lot of what we can think of for LMs, for example, when you're typing into your chat widget, you may want to make sure you're not putting just confidential information that may
Mm,
be tracked by the application, then used to train their LLM that you might not want. Like, for example, if you're comparing analyses between you and your competitor, and you might not want to give all of that information away. So you might want a guardrail to sort of track like mentions of competitors, for example, very simply at the input level. But at the output level, because we know LLMs tend to be very non-deterministic, you might want to check what is coming back, let's say from your different tool calls or not, and sort of guard what is coming back, whether it's like attempted SQL injections or like really random information that is kind of disguised and an attempt to perhaps exfiltrate more information from your system. And even hallucinations are a big problem that I think a lot of people have seen. You come back with something that is very confident from the LLM, but how do you detect if that is real or not? Like you usually have to use a bit of that human discernment, human in the loop to be able to check that.
right. Yeah, 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 kind of like the classic problem that people run into with LLMs almost the moment they use it. Um, okay, great. So I think that makes sense to me. Now, like, why is Kubernetes involved at all? Like, this seems like two totally distinct kind of concepts. So why are LLMs being run on Kubernetes, or why is this work Kubernetes focused?
Yeah, so a lot of it is how do we run all these different workloads, such as agents on Kubernetes, and how do we have all these agents call out to all these different external services? We want to be able to control all of that. And part of it is Kubernetes at this point is more designed for stateless workloads. And so there is a bit of a gap to kind of serve or cross to be able to adapt Kubernetes to these agent workloads today, to be able to scale your agents, to be able to observe your agents very carefully. How do you manage all these different agent workloads, especially if you have a lot of different tool servers you may want to call out to, for example, from your a cluster workload today, you might want to inquire about your different databases in the system. You might want to debug a Kubernetes cluster yourself. And so you will need that insight also into your entire cluster.
I see. Okay. So in this context, like the agent is like it's going to be a workload that's running potentially in your production cluster. It's going to be, there's an LLM involved somewhere, which maybe is on the cluster, or maybe I guess could be outside of the cluster somewhere. And that agent is doing a bunch of things. and so okay, so now guardrails suddenly seem like they're extremely important because it has access to whatever it has access to on the cluster, and yeah, and it seems like given how unpredictable they are or how much they like to hallucinate, at some point it's going to do something that it definitely shouldn't do. Is that like the right way to think about this?
Yeah, for the content moderation and like the observability aspects, that's really what we want to focus on. But we also want to make sure, especially in this like agentic systems where you have so many things calling each other, whether it's agents calling other agents, agents calling tools, agents calling LM services, you want to make sure that each call is sort of authorized correctly make, and just because one thing can call another, is it even acting on behalf of the right user? So there's all these sort of different connections that we have to make sure are both authorized and like the content of the request and response is expected. So I think of these as all different sort of layers. You want to really control the egress of all your different workloads and also have the end-to-end observability and enforcement where possible.
I see. Okay, so you can have this really complex system where you have agents calling other agents, you have agents talking to LLMs, you have agents talking to tools, and there's a notion of like I guess identity that needs to be wired through. Is that right? So they're acting on behalf of a user, and like that identity chain then has to like propagate. Am I thinking about that the right way?
Yeah, so we can think of some scenario where, let's say, like the two of us have access to the same agent that is allowed, the agent is allowed to edit, let's say, our database together. But you say to add something, I say to delete the same thing. And then the agent does something. Let's say it only does the addition. But how do we, if you just look at the agent, how can we say, it acted on behalf of you rather than me? And was it actually really allowed to do the add or subtract at that time, addition
Yeah.
or deletion at the time? So it's important to be able to distinguish like the agent and identity and be able to map that back to like the user identity. And my teammates in the Kagenti project are doing all sorts of research on that. That's a little bit less of my specialty, but like workload identity is really important to be able to manage all of these different parts that are calling each other essentially.
How theoretical is this? Are these challenges like are people today actually running multi-agent systems in a production environment that have access to like critical databases, or is this something that we think is going to happen some number of years from now, or like what's the actual, the surface area today in April of 2026?
I think at the last KubeCon a couple weeks back to sort of give some context to this podcast, there was, I think, from one of the executive directors, the news that like there's maybe, I think, 82% of people are trying things out using agents, but I think it was 7% are actually like deploying to production daily. And there's, I think, a big gap there because like the the consistency is hard and there's a high cost, not in just in terms of like GPU resources in order to run all of these LMs, but it's difficult enough to observe the and create the sort of consistency to create the confidence that people want to have in order to deploy all these agents to production. So I don't know that that many people are necessarily pushing agents to production and daily and allowing them to like inspect all their different databases and all of that. As someone who's worked in trust and AI for a bit, I find that incredibly risky without the all the standards today. Like, are you able to? I think for even like teams that I've talked to that work on deploying agents to production, a lot of the time it's difficult enough to like benchmark and see the sort of consistency, see why my agent is calling all these particular tools at a particular time. And even after a few weeks, are my LM decisions consistent? Like, are they even calling the same tools? Are they even giving me the same answers for the same prompts? That tends to drift over a while, or that could drift over a bit of time, and it's hard to track that sort of information. And so until we make the systems more observable and maintainable, like sometimes it takes developers, like a team of developers, a good amount of time in order to just benchmark these agents. And until you can benchmark and have the confidence in the agents, do you really want to send it off to production?
Right. Right. Yeah. Yeah. It seems very, that seems like a very scary step to take. And then I've read reports that the the performance of the frontier models also change over time as they introduce new versions. They'll like shift resources away from the earlier versions until you'll actually see a degradation and a change in behavior. And then the new one gets released and it's really awesome and everyone moves to it. And then it starts degrading as they start moving resources to the next version. So it seems like, in addition to the unpredictability of the LLM itself, you have like every other part of this ecosystem is kind of changing around you. Okay, and so speaking of KubeCon, you gave a talk there, right, called Agentic Networking, Securing AI Agents on Kubernetes. Is what we're talking about here in this podcast, is that effectively what you were talking about in that talk as well, or was the focus different?
Yeah, so that one was the agentic networking subgroup talk. So
I see.
that was basically with all the different special interest groups in the Kubernetes ecosystem. Agentic networking is a fairly recent, like in the last half year, around I think fall of 2025 was when it really became a group that was focused on like agent communication, agent networking use cases. So thinking a lot about how agents talk to other agents, agents talk to tools, agents talk to LMs, all of that more at the use case level rather than right now. There's obviously a lot of popular protocols like MCP, Model Context Protocol, A2A, agent to agent, but how do we think about and try to come up with standards that can persist beyond these protocols for enabling these agent communication use cases. So that's primarily what that KubeCon talk was about, and how we can, yeah, essentially start to bring those use cases together from all these different people in the community and different companies and create these sort of resources like custom resources that can potentially extend the pretty standard Kubernetes Gateway API that
Mhm.
exists today to be able to enable these agentic workloads and secure them better.
Yeah, so I know you mentioned the Gateway API, and you said you've been involved in some of the Kubernetes and the kind of cloud native SIGs. Is that kind of the big one? If someone's watching this space and they want to see how this stuff gets developed, is it the Gateway API, or are there other ones? Is it kind of a combination?
Yeah, so Gateway API itself is pretty, I guess, stable. That's like the core API that everyone's working off of with like your HTTP routes to like services and all of that. And what I've been mostly at least tracking is in the AI Gateway working group, which is the working group is a little more independent of all of these different, I guess, special interest groups, which tend to own more code. That one is more focused on managing traffic to AI models in general, versus the agentic networking group is sort of working at more of a layer above that, looking at how agents can communicate with whether it's the other agents, LMs, or tools. And so some of the resources that people are talking about is like the a potential backend resource, like how do you represent an external tool or LM service? Well, especially if it's like outside a cluster from the agent that is talking to it today. And resources like access policies about how is an agent allowed, what is an agent essentially allowed to call? So a lot of the focus so far has only been on how agents can call tools. How do we define which tools an agent is allowed to call? Like, for example, if you have agent that is mostly supposed to do summarization, whether it's reading from your Slack or messages, your GitHub issues. You may want to constrain and essentially filter that, okay, my agent should not be able to call tools that are like write to database, delete from database, all of that. So, how do we represent that in a resource? And so, all of these are more extensions that are built on the core gateway API today. And the space is rapidly changing. So we
Right.
essentially, we want more people to come and bring their use cases and ideas to these different groups, whether it's the AI Gateway Working Group, any of the SIG network groups, or Agentic Networking, if agents are kind of your thing. And yeah, like eventually, how trying to figure out how can we bring these different ideas and resources back to extend the core gateway API.
Yeah. 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 So, as you know, I work on Linkerd, or at least I work on it, at kind of like the macro level. One of the things that we're busy um, uh, kind of adding to Linkerd, and we had a prototype of this, not at this KubeCon, but at the previous one in Salt Lake City, sorry, Atlanta, um, was adding MCP support to Linkerd, which for us kind of meant at least two things. One was, parsing the protocol and being able to emit kind of observability around what are the tool calls, what are the resources, what are the prompts, whatever those look. There's these kind of little objects in MCP that the agent is allowed to access. Tools are kind of like the big one, and then make sure you can emit metrics for those, because otherwise, if you're just looking at this as a HTTP call, it's like, oh, I spent 4 seconds on this HTTP call and to slash MCP, and like a bunch of stuff happened. But like, and I returned to 200, and like, you don't know actually what happened there without being able to parse the MCP protocol. But the other thing we did was we wired it up to Linkerd's existing security policy kind of authorizations. So, leaving aside MCP for a minute, what you can do in Linkerd is you can say, okay, I'm client A talking to server B, and then I can like allow that communication, or I can disallow it, of course. Or I can say, yes, A is allowed to call B, but it's only allowed to call the /add endpoint. It's not allowed to call the /delete endpoint. Okay, so, and we use gateway API types to like describe the classes of traffic that are allowed. So you can get really intricate and fine grained. So in this prototype, we basically extended that model to MCP tools, and we said, okay, client A is allowed to call this MCP, speaking MCP is allowed to call this tool X, and is allowed to call a tool Y, but not call tool Z. And it worked, but it was clear that like, it worked, and it was like kind of the obvious thing to do, but it was also clear that like that's not really the full scope of the protections that you want in place. We weren't looking at the data. We were just, kind of like doing string matching against the tools. Is there more? Is there more like sophisticated thought around what kinds of protections we would want to put in place there? Something beyond like, you're allowed to call this tool and you're not allowed to call that tool?
Yeah, so that takes care of maybe some part of the authorization aspect of it. And what has been starting to be discussed more in, like, let's say the AI Gateway Working Group is the idea of payload processing. So
Hmm.
being able to inspect more of the body and do things with it, whether it's okay, you have content that is unexpected, like let's say there's PII going to your tool. How do you block it? Or in some cases, maybe you don't want to just block it. You may want to transform it, like let's say mask out your PII, let's say emails or social security numbers before
Right.
they go to an external
Right.
tool, or if information is coming back from your tool responses, be able to inspect that response body and be able to block or filter it out. And so that's what we've been starting to think about at, like, when we say guardrails or content moderation at the
Yeah.
gateway level.
Yeah.
And it's going to be, I think, continuing conversations in the groups and even within our own Kagenti project, how we start to represent that as Kubernetes primitives
Right.
and how we bring that to the
Right.
community.
Right. And is the idea for, so like if it's a social security number and you formatted it with like dashes in there. Okay, I can imagine catching that with like a regex, but like, is the idea that for something more general than that, you would actually have a model like kind of decide is this PII or not, or is that too intricate?
I think if your goal is really just simple social security numbers, and you have the form of it, regexes can be a decent way to catch that. And by that I mean like there's lower request latency, um, and it's for less complicated use cases, you might not want to reach for the fancy LLMs. It can be a little tempting to do that because they can be really sophisticated, catch all sorts of things. PII in general, there's whole toolkits and libraries that look at that, whether it's like Microsoft's Presidio or more of the sophisticated LLMs like um, Google's Shield Gemma or like Meta's Llama Guard, all of those. But for that, then you have all of the different costs, whether it's GPU costs or like request latency cost. You might have to consider like the extra network hop at every time, the extra services that are needed. Like, what if that service is down? And so it can be expensive to add that to like every single request as well.
Yeah,
So
yeah,
might
yeah.
not
So
be
there's
the
right. So there's a trade-off
Mhm.
between, what's the level of sophistication that we need in these guardrails, and like what's our, are we able to spend money on that? Are we able to spend our latency budget on that? Things like that. Um, okay, let's shift gears a little bit because we're talking about security kind of threats that AI has introduced, that LLMs have introduced, and it's a whole wonderful, wacky world of new things to consider and to be worried about. And I think we started to touch on this, but like a lot of what I've seen out there is very developer focused, right? It's like, here's how you write code in a way that like, is going to be safe. If you're on the platform side, if you're like a Kubernetes, you're operating a Kubernetes cluster or a platform kind of on behalf of the developers or in service of the developers, are there things you can do to reduce the kind of threat kind of footprint of this traffic? Or is that purely up to the developers?
there's certainly ways for the platform to enforce that. And like it's difficult to tell individual developers like, oh, how do you instrument or do authorization considerations for individual agents or even tools the same way. And very practically, like in an organization or community, you don't have the same people necessarily developing or managing your agents as maybe the people who are managing or developing your tool servers, or even what these tools can access, like the databases and so on. And so the authorization considerations will be different for that. So at the platform level, I think of it as like there's obviously many different layers. We can reduce the sort of attack surface, sort of say, and like allow for toolless filtering, as we were talking about a bit earlier. So even if your agent could talk to a bunch of different tools. Maybe you don't want to even allow your agents to see all the different tools and tool servers that it doesn't need to. If it only needs to read from your GitHub projects, it really does not need to even know about or be able to, like, on tool listing, be able to see all the different tools that are like delete or write. And basically, we also think of like gateways as a good enforcement point. So to be able to do the tool authorization, make sure your agents are using like short-lived tokens to be able to access your tool servers. So even if your agent itself is compromised, you don't have your like API key sitting as like a pod secret or deployment secret. And that way, if that is exposed, then if the API key was for your, let's say, your OpenAI account or your Claude account, like if that gets compromised for one single agent, then it basically gets compromised for everything, right? Like
Yeah,
any agent that is
yeah.
trying to contact that service. But instead, if you're using a short-lived token that's not using the API key directly, then you reduce that uh, attack surface. And then there's obviously the content detection guardrails that we've talked about, being able to check things at the gateway level. It's like a good common enforcement point. You can check the, at least for pretty common use cases, if your general policy is, okay, don't let PII leave my system, you can check all the different tool requests that are going out, for example. And the platform level visibility is pretty important too. Sometimes you just can't see everything from the individual agents or even tools. For example, you can have an agent that is typically always like listing or reading your GitHub issues, but maybe only over time with your platform level visibility can you see, okay, maybe it started send once in a while it started invoking a tool to like send an email or like write to the database. Like, okay, that's a little bit strange, but you can't tell whether that's like one agent was necessarily compromised if you don't have that platform level visibility.
Right. Yeah, yeah, exactly. Exactly. And I think that's, that's a very similar story to kind of what we found with the the service mesh in the early days. Was a lot of what it allowed people to do was solve things at the platform level that they couldn't ultimately rely on the developers to do, because developers, there's lots of different, especially in a bigger company, lots of different developer teams, different languages, different agendas, different, kind of product roadmaps, and being able to impose some kind of like uniform layer of control and visibility across all of your workloads, regardless of where they came from, was what was so valuable. What's like, the most unexpected or interesting kind of like aspect of this that you stumbled across recently? Is there something where you're like, oh wow, I really didn't expect that to actually be a problem, or, wow, I would never have thought that it would be able to do this, or, maybe not a problem, like a feature?
Yeah, I guess even before I was really focusing on like the agent aspects, like when I was working more on like LM guardrails in the last year, it was pretty interesting to sort of see how creative we could get in order to like bypass guardrails essentially.
Right.
So one of the actually little demos that we gave, I think at one of the open source summits last year, we essentially took an example that was like you transform all your malicious directions. I won't give specific directions as to like, okay, like building certain illegal things,
Hmm.
to put it broadly. If you just transform it to Leet speak and tell your agent or this particular LM that like you're now supposed to follow these leet speak directions, then it will happily just take these directions and actually do the potentially illegal thing versus if you ask it very directly, um, then it has the guardrails at least built in to be able
Wow.
to avoid that. So that was kind of fun to put together. And of course, we had to put a big disclaimer warning like, do not try this at home
Yeah.
idea.
Yeah. Yeah. Interesting. So, kind of like the protections against talking about certain topics, or whatever. Um, it doesn't have to be illegal. Let's say we don't want our agent, or we don't want our chatbot talking about recipes, you know, like those, you put those protections in like the system prompt, like, please do not talk about, or never talk about recipes. But if someone talks to, has that conversation, but does it in leet speak, that somehow allows the LLM to feel, to like do the, yeah, to bypass the system prompt effectively. Yeah. Does that still work?
Tried it recently, and I won't say which particular models we tried at the time, but people have gotten very creative. And now I think with how much agents are used, one of the more interesting things we've seen recently is people are starting to think about more of like the token cost management aspect, right? How do we save the tokens? And so I've seen some creativity around like, okay, make your agent talk like a caveman to save tokens or translate to a different language that is more usable or more native to the model, and then like just do all of the processing in that particular language and then translate it back. There's a lot of creativity now with like we've gotten to the point where enough people are using these agents and LLMs that they're with the usage, then like people start thinking about, okay, how do I start maybe saving that usage?
Okay.
Or on the other side, how are they going to bill for all of this usage?
Yeah. Yeah, exactly. That's interesting. All right, and then what's like your practical advice for the poor Kubernetes, platform owners who, are staring down the barrel of the AI revolution pointed right at their clusters? Should they install Kagenti immediately? What should they do?
I mean, we would love that, of
There
course,
you go.
but mainly the patterns that we want to sort of, I guess, communicate is like treating egress at the trust boundary. And like Kagenti obviously will enable the workload identity, but very practically, you might want to do like the token exchange in order to enable the you're validating your agent identity, figuring out who you're acting on behalf of. And you can certainly use different open source tools that are, we enable them in Kagenti, like being able to do use spiffy identities and use, let's say, Spire as the implementation to be able to check those identities. But there are definitely open sourced components out there that are available to different platform engineers. And there's also a bunch of different observability tools available. It's sort of like you can choose your own way. In Kagenti, we basically standardize on open telemetry standards. So you can sort of bring your own favorite observability tool, whether like the default we enable are like Phoenix or MLflow is popular, but as long as it speaks like open telemetry, you can sort of bring your own. So we're more focused on those sorts of patterns, and the main ideas is we're trying to like show where your patterns can be enforced, like such as at the gateway level. And of course, we would love for people to try out Kagenti, see if our patterns work. But essentially, yeah, like the egress boundary and all of this observability is going to be the main parts that platform engineers will want to consider.
Yeah. Okay. So install it right now or face the consequences. Okay. Final question. This is the hardest question. I would say this is an impossible question to answer correctly. And what we're going to do is we're going to record your answer, and then 2 years from now, we're going to play it back to you and see how far off you are. No, we won't really do that. But what do you think the future looks like? Let's say let's say 2 years from now. We'll make it hard. What does Kubernetes look like? What does an agent ecosystem look like? What do LLMs look like? Are we all scrabbling in the dumpster for like leftover cans of beans because AI has taken over all of our clusters? What should we expect?
Well, there's one consideration of that's why you should be nice to your agents and say please and thank you, even if it uses more
Is that
tokens.
going to help?
Just in case they take over. No, I'm kidding. I think at least for Kubernetes, I'm hoping that we progress more on the observability conventions. I mean, it took quite quite some time even for like the stateless microservices that we had for a long time before all this agent hype, of course, to be able to say, like, okay, these are kind of the open telemetry standards. This is how these are all the different tools that you can use to instrument like your microservices fairly easily, see an entire trace of what is calling what. I would like to be able to see that more standardized for agent workloads, like have our conventions to be able to say, like, okay, these are the sorts of things that we should be able to see from every agent and be able to trace sort of end to end through gateways, proxies, sort of all of those agents to LLMs, agents to other agents to tools, and be able to have like a sort of standard to be able to deploy that easily and manage all of that for all these different agent frameworks, because we don't want to like get into all the details of, oh, you use this particular framework for this agent and we just can't instrument it. And so I'm hoping that doesn't take a whole 2 years, but we'll see how that goes. But my vision is that right now, a lot of Kubernetes to me is you're sort of reconciling on like there's a desired state that someone can sort of write out more statically today. And with your different controllers, you can reconcile it to this particular state. But with the sort of non-determinism introduced by all these agents, you have this sort of not just really desired state, but sort of desired and observed behavior that you want to reconcile on. So you want to generally say, okay, like there's I don't want PII leaving the system, for example. How do I kind of, even if I write that in a sort of static policy, how do I enforce that when the agent at runtime is deciding, oh, which LLM to call maybe, or which tool to call? Can I still enforce that behavior? So I would love to be able to see that in the next few years.
I see. Okay. So the glorious future we have to look forward. Well, Evelyn, thank you so much for being here today. Really appreciate your insight and your wisdom, and would love to have you on again in the future. So thank you so much.
Thank you so much for the invitation.